Hello, everybody. Welcome to 2024 and Approachable AI. Today's topic is Retrieval Augmented Generation, how and why to build it. My name is Mikko Peltola. I'm from ACX and I'll be your host today. And I have Brandon Crawford here with me today. He's our technical lead. Welcome, Brandon.
Hi, Mikko. Nice to be here.
Excellent. Good to have you here. So ACX covers the different digitalization and technical needs of companies. We do envision, design, and engineering. We have research and insights capabilities, UX and visual design capabilities. Quite often our projects are related to artificial intelligence, but not always. We also do other kind of digitalization projects. We have a strong front-end development capability and secure back-end and DevOps capability. And those are very much what Brandon will explore today. We have capability to deliver everything that he talks us through today. We have a long list of topics to cover. We're going to start about the large language models, why and how they can be customized. Then we move on to the retrieval augmented generation work. Where is it good at? Why should we choose it? We go a little bit more technical, looking at the architecture and how Microsoft supports the RAG. We look at the supported data and then the different system prompts. So that's what we're going to cover today. At this point, I'm going to hand over to Brandon and let's hear more from you.
Sure. Yeah. Hi, Mikko. I'm here today to talk about retrieval augmented generation, and how our clients are using it today, and how companies are looking to use it in the future to create custom LLMs.
Okay, sounds good. Let's get started. So first question for you, Brandon. Why would somebody consider using a custom large language model?
Yeah, so generally speaking, we see two use cases for custom LLMs. The first one is to try and generate things with consistent tone. So say you're using your LLM to build something like a chatbot or something that responds to emails. Depending on who it's interacting with, you might want it to respond more formally or more casually, or with a specific personality or as a specific person. And we see this sort of custom work being done by companies like OpenAI with things like their custom GPTs. The other reason we might see custom LLMs is because companies want to use their own data in LLM responses. So if you've used a tool like ChatGPT, you probably are already aware that if you query it for information about your company, it doesn't respond well, and that's because it doesn't have access to that information. It wasn't trained on it. And lots of use cases clients have are use cases where they would like their own data, their own documentation to be presented by the LLM as part of the query responses.
Okay, so let's assume that that's the case and we have a need. We want to customize the LLM. What kind of methods are there available for us?
Yeah, so generally speaking, there's three ways to customize an LLM. So the first way, and probably the way everybody thinks about, is you can build your own. You can take your own data and combine it with data that's out there and build your own LLM. This is a complicated process. There's a lot of there's reasons. There's a lot of very smart people at places like OpenAI building these things, but you can do it. A more common approach to doing the customization is an approach called fine-tuning, where we take an existing LLM and we perform a little bit more training on it. So we take, OpenAI's existing LLM, we get our own data, we run an additional training step, and we get a new LLM that has our own data in it. And then the third approach is something called Retrieval Augmented Generation, which is what we're going to talk about today. And Retrieval Augmented Generation, or RAG, is a way of customizing LLMs without having to do these training steps. So instead of doing the training, we provide the data at query time and tell the LLM to use that data to answer the questions.
All right, cool. So let's then talk about the Retrieval Augmented Generation. How does it work?
Yeah, so let's take a look at a simple example here. So generally, retrieval augmented generation is sort of a two-step query process, as opposed to just querying and getting a response from the LLM. What you do is you submit a query, and instead of immediately going to the LLM, we submit the query to some kind of search engine, some kind of custom data source that contains your data. We then retrieve from this data source any data we think will be helpful to the LLM for answering the query. We take that data and we provide it with the query to the LLM. So our querying becomes this two-step process where we provide your custom data to the LLM and instruct the LLM to respond using that data. As this sort of slide shows, there's a little bit of an underlying process to it. So in this example, we have a user trying to discover how many employees are at their company. So we can see in this example, you make this initial user request and we generate a search request from it and we send it to the search engine. The search engine responds with something like, well, there's a company directory page, and the company directory page shows there's 30 employees and 60 contractors and 2,000 customers. And so we provide that company directory page to the LLM beside the query. And we say, look, using this information from the search engine, can you answer this question? And then we get the answer to the question back. We'll provide that to the customer.
Okay, so it's like you don't have like a closed book exam, but the LLM has an open book on next to it, and then it can augment its understanding with that. Okay,
Yes, very much so.
Okay, good. So what are the benefits? Why would we choose to use the RAG then?
Yeah, so as I touched on briefly before, the big advantage to RAG is that it doesn't require retraining. So these other approaches, building a full model or doing fine tuning, require this sort of expensive retraining process, which is expensive both in terms of like computational resources. You have to do training, and so you need machines and GPUs. But it's also expensive in terms of time. It takes a while to build an LLM. So one of the nice things about RAG is that we can update our search engine, we can update our data, and basically receive updates to our LLM responses in real time. Um, Another nice advantage to using something like RAG is that typically we can leverage existing pieces to answer questions. So if your documentation is in something like Confluence, for example, Confluence has already got a search engine built into it. We don't have to do anything to extract all your data and perform training on it. We can just use the data as it is stored already today. It makes the implementation a lot simpler. Um, the other major advantage to RAG is we can use data sources besides free text. So training an LLM, typically, you want a lot of documentation and stuff, and that's sort of the use case we think of. But for example, what happens if all your data is in a database? It's all tabular data. Well, training an LLM on tabular data is not really something you can do. And so you can use something like RAG instead to query a database rather than searching free text documents and returning relevant information. Yeah.
Okay, excellent. So you've now articulated us like how this works and what are the benefits. So let's look under the hood. How does the architecture look like for an RAG?
Yeah, so the RAG architecture is relatively straightforward. As we saw already in that first example, you sort of end up with three or four components here. So the main component is this REST endpoint that is going to handle augmenting your queries. So rather than hitting the LLM directly, you're going to have something, a piece of middleware, basically an Azure function, a Lambda, some kind of application that you query. That application is then going to reach out to some kind of data storage or document store. Typically, we see things like Azure Cognitive Search, AWS Cognitive Search, Apache Lucene, or if you have a document store already in place, something like Confluence. And then once it's reached out to that piece, it's going to reach out to whatever LLM implementation you want. And one of the nice things about RAG is we can use an off-the-shelf LLM. We don't have to build our own. So we can use OpenAI's LLMs, ChatGPT, Google's LLM, something like Bard. Really, whatever piece we find gives the best results. And then typically with these sorts of implementations, we would have some kind of interface on top of our middleware. So this might be an interactive web page. It might be something built into an email program or a chat program or something like that.
Okay, good. So we usually use Microsoft Azure as an example. So how would we build this kind of architecture using Microsoft Azure?
Yeah, for sure. So I've got a little bit of an architecture diagram here. And as you can see in the architecture diagram, it really is those three components. We have in this architecture Azure Static Web App to function as our front end, function as our dynamic interface. We have an Azure function written in Python here that actually handles the augmentation step. So it's receiving requests from the front end, pushing them back to our search engine, contacting our LLM. We can see in our backend, we have Azure Cognitive Search. Azure Cognitive Search is a very popular way to do document search in Azure. What you do is you take all your documentation and you upload it to Azure Blob Storage, and then you run Azure Cognitive Search on top of it, and that indexes all your documents and basically builds a little mini search engine on top of all your documentation. One of the nice things about using Azure is that it integrates well with OpenAI. So Azure provides an OpenAI endpoint as part of your Azure deployment. So we deploy these Azure OpenAI endpoints, and our Azure function reaches out to cognitive search, gets the documentation it needs, and then reaches out to the Azure OpenAI endpoint to do the LLM generation, and then responds accordingly to our user's query.
This is a very good demonstration. We've been talking many times how much of the heavy lifting in AI has already been done. So Microsoft and the other big guys, they've invested so much into this space that largely building great AI solutions is about building great solutions. The AI part, that heavy lifting has been already productized. It just needs to know which components to use and how. Good.
Yeah.
So then the remaining important part is data. You need good quality data to build good quality AI. So can you tell us a little bit more about what kind of data types can we support with this?
Yeah, so this example uses just like free text. So we're taking a company's documentation in this case and loading it into blob storage. But as I mentioned before, one of the major advantages to RAG is we don't have to use free text. We could replace something like the Azure Cognitive Search and the Azure Blob Storage with something like a Mongo database or even a more structured database like Postgres. As long as our augmentation function understands how to search our data set, really we can do whatever we want. And as I mentioned before, one of the nice things about this is we can do this in real time. If you have real time data coming in that you want to query with an LLM, we don't have to do this retraining step. We can just have the function perform querying into this real time data stream and get the information back and back to your users.
Okay, so that's how the system works. Then prompts are how we are guiding the system. So what we are asking and what we expect to get out of them. So what types of prompts does our RAG endpoint then use?
Yeah, so let's take a little bit of a look at how the augmented endpoint works under the hood. So as you can see in this example, we've got a short example here where we're trying to get a summary of a product page. So a user requests that summary, and we reach out to the search engine. We say we'd like to generate a summary. Can you give us the project page back, please? And as you can see in this example, there's actually two messages we send to our LLM. There's a user message and there's the system message. So if you're familiar with using tools like ChatGPT, you're already familiar with the idea of like a user message or a user prompt. That's what you type into ChatGPT and that's what's sent. But you may not be familiar with the idea of a system prompt or the system message. So this exists in ChatGPT that has this system message, but it's hidden from the users in the typical interface. When you're interacting with the LLM through code, though, you can specify this system prompt. And what this system message does is lets you tell the AI, this is how I'd like you to respond. So you can see in this example here, we've got the user message as a query. But what we've also got here is the system message basically saying, look, use this information the search engine has provided. Don't guess what the answer might be. Do not hallucinate. If you don't know the answer, it's fine. Inform us you don't know the answer. Don't make something up. And doing this, we kind of lock down what the AI can do, how the AI can respond. And so phrasing these system messages correctly is very important.
Okay, so how can we best choose the system prompts for our RAG system?
Yeah, so as you can see in the example above, we have the system message, and what we're doing is we're using a prompt that tells the AI, don't guess. Respond, if you don't know the answer, just say you don't know the answer. And we want a prompt like this if we're doing something like a customer service bot. We don't want it to guess. We want it to say these are the things, and if I don't know, then I don't know. Um, but the problem with prompts like this, and the reason writing a system message is hard, is if the query was something like, what is the SEO for the widget project page? A query like, or a system prompt like this will cause you problems. And the reason is the product page doesn't contain any information about how good its SEO is. Knowing about SEO is something the LLM has to sort of pull from its memory. And so what ends up happening is you want system messages that are both, locked down enough that the LLM won't guess in some cases, but also the LLM will kind of use its own knowledge. And so really for selecting system prompts, we should very carefully consider what use cases the LLM is going to be supporting. We're okay with it hallucinating a little bit in cases like the SEO case, or in cases like where we maybe want it to write a blog post or something like that, where someone is going to review and make sure that the information is correct. And so we can allow the LLM a little bit more creative freedom. Um, yeah.
Okay, yeah, makes sense. So if we want to use one system for a few different kind of use cases, how can we then like differentiate the system prompts for different use cases?
Yeah, so this is the challenge, right? I mean, you have all these different use cases, and you need to select the right prompt. The most obvious way to do it is just to have your users select a prompt. So, depending on who you're, giving access to, you might say, customers get this prompt and SEO specialists get this prompt. And this works to a point, but probably what you'd like to do is select this kind of stuff automatically. You'd like to choose from a list of prompts which one you think would be the best in each case. And to do this, what we could do is we can leverage our LLM again. So in this example of an augmented endpoint, what we actually do is before we perform the search, we actually reach out to our LLM and we say which one of these system prompts would be best. Um, in this example, we're writing the short summary of the product page, and we're saying who would be best to write this, a technical writer or an SEO specialist. And we would have separate prompts depending on what was chosen. The tech writer's prompt is a prompt where you don't hallucinate, you don't guess. And the SEO specialist prompt is a little bit more use your internal knowledge and examine this website to give good advice about how the SEO should be set up. What's nice about this is LLMs are really good at this task, because under the hood, an LLM really is just a system for determining how close, tokens or how close words are to each other. And so it can take a sentence and quite easily discover which of your prompts are most similar to that sentence, or which of your prompts make the most sense. And then you can use that prompt.
Okay, that's interesting. So it knows, it just wants to be asked first, so it can give you hints like how it should be asked in the second question.
Very
Okay,
much so, yeah.
right, yeah, okay. All right, then what can we do if we have multiple data sources?
Yeah, so this is another use case we see quite often where clients have documentation or databases, but of course, information is spread across many places. So, you've got some of your documentation Confluence, you've got some documentation, written in old Microsoft Office documents, maybe like stored in SharePoint or something like that. And we want to bring all this information together into one LLM. Once again, one of the things that's nice about doing something like an augmented endpoint rather than retraining is we don't have to gather all this documentation to one place. All we have to do is add some kind of layer on top of it that's capable of searching all these different places for the information we want. And once again, what we can do is we can leverage our LLM to decide where we want to search. So in this even more complicated example, what we can see is that we have two data repositories. We have the foo search engine and the widget search engine. And when we receive a query, the first thing we do before trying to discover which system prompt to use or searching for the data is we ask the LLM, which of these two search engines do you think is most likely to contain information relevant to this question? What we can do with a data classifier request is we can customize it based on what engines are available. So, if you've got documentation that's, older, that's in Microsoft Word, newer in Confluence, sort of a thing, we can ask a classifier. We can say, does this look like a question that's more likely to be answered by legacy information or by more recent information? And then we can query the appropriate data source. And similarly with, tabular data versus, documentation and things like that, we can select between those using the LLM.
Okay, excellent. Hey, thank you very much, Brandon. This has been a great insight into how the LLM works, how the RAG works, what are the benefits, what's the architecture, how to build those with Microsoft Azure, and looking a little bit deeper into the prompts and data sources. So this has been very helpful for me. I hope it's been helpful for our listeners as well.
Thanks, Miko.
If this was interesting for you, you want to learn more, please visit our website. We have 10 other webinars and presentations we have recorded, and also we have other material. For example, there are a couple of blog posts that Brandon has written where he's touching the same topics we covered today. So if you rather look at the written format or want to have a recap, that's an excellent place to go for more. So once again, if you have any questions, any comments, please feel free to reach out to us. We are happy to help you with your AI envision, design, or development work. We will continue these webinars. We have a live presentation in South by Southwest, so stay tuned for more. Thank you very much and have a good day. Bye-bye.